Hey, fourth and fifth graders, it's Mrs. Seals back for our next science lab. Fourth and fifth graders are both talking about and doing the same lab this week, so I'm combining them into one video. So fourth graders, you have been talking about force and motion for a couple weeks now. We talked about pushes and pulls. We talked about gravity. This week, we're going to be talking about friction. Fifth graders, you are just now starting your unit on force and motion. But friction should be something that sounds familiar to you. You learned about it last year in fourth grade. So let's get started talking about friction. So fourth graders, your target says I can complete a descriptive investigation to explore the effect of friction on an object. And fifth graders, I can design a simple experimental investigation that tests the effect of force on an object, including friction. So let's review that force is a push or a pull that can change the position or motion of an object or material. So when something is pushed or pulled, it changes position, which means it changes where it is located, and it gets put into motion or it moves. Friction is a force that acts in an opposite direction to movement. Friction is a force that holds back the movement of a sliding object. Surfaces that are rough or bumpy have more friction. Surfaces that are smooth and flat have less friction. This is why when you are roller skating or skateboarding or riding a bike or rollerblading or anything like that where you have wheels that are turning, this is why it is much easier to do those activities on a smooth, flat surface like a driveway or a sidewalk or something like that, as opposed to the grass. Since grass is more rough and bumpy than a sidewalk or a driveway, it has more friction. That means it has more force pushing against you, making it much more difficult for you to be able to ride your bike or roller skate or skateboard. Okay. Smooth flat surfaces have less friction. They have less force pushing against you, so it's much easier to do those things. Same thing with if you've ever been to the beach and you've tried to run on the sand, it's a lot more difficult to run on the sand than it is a smooth flat surface. Sand has lots of friction. So today we're going to do an investigation or an experiment to observe friction acting on an object. In fourth and fifth grade both, in this unit about force and motion, this unit also goes into what we call experimental design, which means understanding why experiments are set up the way they are, understanding why certain things have to be done a certain way, and things like that. So we're going to also be talking about that in today's experiment as well. So to learn about friction today, we're going to be using a toy car. So in the classroom, the kids that do this investigation will all be using the same toy car. Okay, that's very important that we all use the same toy car. And we have different surfaces, and we're going to see which surface has the most friction. So the surface that has the most friction will be the one that stops the car the soonest and doesn't let the car go as far. So here are the surfaces that I'm using. The kids in class, each table group will have 3 different surfaces. I'm going to use wax paper, which is very smooth, very flat. This is used if you bake, you put it down on the cookie sheet to keep your things from sticking to the pan or the cookie sheet. I'm going to be using sandpaper, which is very rough and scratchy. And I'm going to be using bubble wrap, which everybody knows what bubble wrap is. You can pop it and there we go. It has those little bubbles in it. So before we do the experiment, I want you to make a hypothesis. Which of these three surfaces do you think will have the most friction? The wax paper, the sandpaper, or the bubble wrap? So in other words, which one of these surfaces is going to stop the car first or sooner and not let it go as far? Go ahead and make your hypothesis, and when you're ready, you can continue the video. So I am going to move to the floor for this so that I have more room and so that everybody can see what's going on. So this is an experiment where, yes, it would be easier for you to see and understand if you were here in class. Since you're not, we're going to do the best we can. So I don't know if you can tell, but right here, I have made a little ramp with these books. So what I'm going to do, we're going to start with the wax paper. And in fact, I think I'm going to scoot this back a little bit more just so you can see better. So you can see how far the car goes. All right. So I'm going to start with the car up at the top of the ramp. I'm not going to push or add any force to the car. I'm just going to let it go. All right. So now what I'm going to do, I'm going to use my meter stick. I'm going to measure how far the car went in centimeters. I'm going to start measuring from right up against this book all the way to the front end of the car. And when I do that, I get 65 centimeters. So the first trial on the wax paper, the car went 65 centimeters. So on my paper, I'll show you what it looks like in just a second. I have recorded the name of the surface, wax paper, and the distance of trial 1, 65 centimeters. Let's talk about that word trial that I keep using. So a trial is an attempt. In this experiment, we're going to be doing 3 trials or 3 attempts with each surface. And then we're going to be finding the average distance of each surface. So this goes back to talking about, let me sit, this is going to be a minute. This goes back to what I was talking about with experimental design. Why do you think that we're doing each surface 3 times? Why would I need to do 3 trials of each surface? Any ideas? Hopefully you have thought of that it's because this is going to make our results more accurate or more reliable. If I just did each surface 1 time and went with those results, we don't know if those results are fully reliable. The more times a scientist can conduct an experiment, the more reliable, the more accurate those results are. Because any number of things could happen. I could maybe accidentally apply a little bit more force without knowing it. Maybe the car could kind of swerve and go off to the side. Maybe there could be something in the way that stops it. We don't know. Lots of things could go wrong. So if we just do 1 trial of each surface, we don't know how reliable our results are. So we're going to do 3 trials. If we had more time, we could do 4, 5, 6, 7 trials, as many as we wanted. The more times we do it, the more reliable and accurate our results are. But for the sake of time, we're going to do 3, and then we're going to find the average. All right, so that was my first trial with the wax paper. Let's go on to trial 2. I'm starting at the top. I'm not pushing. Oh, see, that's not a good one. That one went off to the side. I'm going to try that again. Ooh, much better. All right, nice and straight. Measuring all the way up against the book to the front end is 70 centimeters. So I'm going to record on my paper. That was trial 2 for the wax paper, 70 centimeters. All right, one more trial for the wax paper. All right, it came off a little, but we're still gonna go with it. All the way against the book to the front of the car, 78 centimeters. All right, so I've done all 3 trials with my wax paper. So now I'm going to find the average. To find the average, what I'm going to do is I'm going to add up my 3 trials. So I'm going to add 65 plus 70 plus 78. And I'll just kind of do that on the side of my paper here. 65 plus 70 plus 78. When I add those up, I get 213. Okay, but I'm not done yet. To find the average, what I want to do is I want to divide 213 divided by 3. Hold on. Is that right? It is. Sorry, I second guessed myself. I'm going to divide 213 by 3 because we did 3 trials. That's going to tell me the average. All right, so when I divide 213 by 3, I get 71, exactly. So that means the average distance that my car traveled on the wax paper was 71 centimeters. I took my 3 trials, added them up, divided by 3 because that's the number of trials I did, and my average is 71. We're going to repeat that with the sandpaper. All right, so let me switch out my surfaces here. Done with the wax paper. Moving on to the sandpaper. All right, starting up at the top. Again, I'm using the same car. I'm using the same height of ramp. I'm applying the same force, which is I'm not pushing it, I'm just letting it go. We'll talk about that in just a minute, all those changes or all those different parts of our experiment. All right, it's up at the top. I'm letting it go. It went off a little bit. We're going to go with it. And we got 76 centimeters. So I'm recording. Trial 1, sandpaper, 76 centimeters. All right, let's do trial 2. Very different results than my first one. This time I only got 43 centimeters. This is why we do 3 trials. 76 and 43 are very different. All right, and one more. $47. All right, so let's find our average. So I did my 3 trials with my sandpaper and I got 76 centimeters, 43 centimeters, 47 centimeters. So I'm going to add those 3 numbers up. 76 plus 43 plus 47. When I add those up, I get 166. Okay, now I'm going to divide by 3 because we did 3 trials on the sandpaper. Okay, so when I do that, I don't get an even number, but we're gonna round. I got 55 and 1/3, which we're gonna round down to 55 because that's not more than half. We're not gonna round up to 56. So that means my average distance that the car traveled on the sandpaper was 55 centimeters. I added up these 3 numbers, 76, 43, and 47. I got 166. I divided by 3. I got 55 and 1/3. Okay, so far, the average distance my car traveled on the wax paper was 71 centimeters. The average distance my car traveled on the sandpaper was 55 centimeters. So far that means the sandpaper has more friction than the wax paper. 71 is bigger than 55, but remember, we're looking for the one with the most friction, which is the one that stops the car, pushes against the car more to stop it. And that would be the one that lets it travel the least distance, which so far is the sandpaper. We're going to do one more surface, which is the bubble wrap. So let's go ahead and do that. Oh, might help if you could see, right? All right. All right, here's our bubble wrap. So starting up at the top, I am not applying any force. Whoa. It even pushed so hard that it moved my piece of paper. All right, so I'm starting up against the book. To the front of the car is only 8 centimeters. Oh my goodness. So bubble wrap, trial 1, 8 centimeters. Yikes. All right, let's go to trial 2. Starting at the top, not applying any force. Goodness, this bubble wrap is strong. It's pushing my paper. Trial 2, 7 centimeters. All right, and then trial 3. A little bit further that time. 16 centimeters. Wow. All right, so I'm going to come back up here because we are done collecting our data. Now we need to analyze it. So I'm going to find my average of my bubble wrap. I have 8, I have 7, I have 16. When I add those up, 15 plus 6 is 21. 3, I get 31. 31 divided by 3. 10 and 1/3, we're going to round to 10 centimeters. All right, so I'm finished collecting all of my data. And the important thing that I want to look at is this last column, my average of 3 trials. So this tells us the average distance that the car traveled on the wax paper was 71 centimeters. The average distance that the car traveled on the sandpaper is 55 centimeters. The average distance that the car was able to travel on the bubble wrap is 10 centimeters. So the first question says, which surface had the most friction? I'll give you a second to think about it. So most, we're not looking for the biggest number in this case. The surface with the most friction, sorry, it's getting warm in here. Woo. The surface with the most friction is the surface that stopped the car, didn't let the car go very far because it was pushing against it with lots of force. So that would be the smallest number actually, which would be our bubble wrap. So out of our 3 surfaces, the bubble wrap had the most friction. The next question says, which surface had the least friction? I know it says least, but we're not looking for the smallest number here. We're looking for the biggest number because the surface with the least friction did the worst job at stopping the car. It let the car go further because it was not pushing against it as much as the other surfaces. That would be our largest number, which is our wax paper. Our wax paper had the least friction. Then I want to talk about this next question. What was the variable in this investigation? So another part of experimental design is when you design an experiment, you can only have what we call one variable. This means the one thing in the experiment that changes each time you do it. I used the same ramp and the same ramp height. I used the same car, and I applied the same amount of force to the car each time. The only variable in this experiment, the only thing that changed each time I did it was the surfaces that I pushed the car down on, or I let the car go down onto. Okay, now the reason why it's important to only have one variable in the experiment is because you know that that's the reason for your results. So let me explain. In other words, if I changed out the surfaces each time I did this, like I just did, and I did it again, but this time on each surface, I used a different car. I have a lot of toy cars. Maybe I could change, maybe for the wax paper, I could have used a Ferrari. And for the sandpaper, I could have used the Hummer. And for the bubble wrap, I could have used the Corvette. Okay. The reason that that would be unreliable is because we would have 2 variables then, the car and the surfaces. And the reason why you can't have 2 variables is because then when you look at your results, you don't know if your results are based on that variable. In other words, I wouldn't know if my results were because bubble wrap truly has the most friction, or if it's because the Corvette just stops sooner than the other cars. Maybe it's built differently. We don't know. If you have one variable, you know that that's the reason for your results. We know that bubble wrap truly has the most friction because all of the other parts of our experiment were the same ramp, the same ramp height, the same car, the same amount of force. So the variable in this investigation was the surfaces. And then the last question says, why were 3 trials performed on each surface? And I explained this earlier. That is to increase the reliability and the accuracy of our results. We saw that on a couple times we got very different results. On the first trial with the sandpaper, I got 76 centimeters. If I just went with the first trial, that would mean the wax paper had more friction than the sandpaper. Does that make sense that smooth, flat wax paper would have more friction than rough and bumpy sandpaper? No way. But because I repeated the investigation multiple times, I was able to increase the reliability of my results. All right, I hope you had fun learning about friction and some experimental design. I will see you guys next week. Bye-bye.